is Amanda Robinson, and this tutorial is part of the Abuja Music Group Machine Learning course. So today we're going to talk about the Purr package, which is part of the tidyverse packages. Tidyverse package, of course, and also Purr is part of those packages, a group of those packages. So Purr package normally helps us to deal with the data sets and also lists. But you can really somehow you can define a package, a data frame, in a way that it is a list of what? It's a list of vectors, and those vectors are can contain the same number of elements. So that's why we can use the Purr package to deal with also the to deal also with that to deal also with the data. So we're going to look at it today. So again, so here you have already imported the tidyverse package, but you can do it, and if you don't have it, you install it. You can install it in your studio from Cran. So this we're going to mainly use the empty cast dataset. We're going to use the empty cast dataset, which is also comes along with R. And if you have R, if you've installed R, that means you have the empty cast dataset. But just for illustration and to be with the same page with everyone, let me first show you how the tidyverse package looks like. So I mean the empty cast dataset. The empty cast dataset, you can see it has 32 rows and 11 columns, and these are the columns. If we have to read more, if you want to read more about it, press question mark. It is guys. So this is more information about the columns and if you want to really get what exactly we mean. So how can we use Purr to look at such a data set? So in such a data set, if we want to get factor variables, because if you look at this documentation here, you can see that there are some variables which are factor variables, but here all of them are represented as their double variable. That means they are numerical. All of them are represented as numerical, but which is not right. So what if we want to change the sum of them, like this is V, VS, and M, and gear cab. Here you can look at what they really mean, the number of gears and number of what. So here, what if we want to change all of these, those that are supposed to be factor variables into factor? So if we really want to do that, you can use this pipe. This pipe is compatible with also the Purr package. So if you get the empty data set and you select those rows that you feel which are supposed to be factor variables, and you want to change them to factor variables. So let's first change this to this empty cast to a table. For us to visualize it and see where we are. Tables can work far better than normal data frames. So let's select. If we look at those if you can see these are the factor variables we want to change into factor. So if you get them and you select them, this select function is from the dplyr package. So you select them, and then after that you assign the result of these columns. Like I said, this is like you can treat this as a list of vectors. So and then after that you pass it to the map function from the Purr package. So after that, then you pass on the function which is supposed to iterate over this column. So what I want to do here, I want to change this column to factor and then move on to this column to factor and this column to factor and this column to factor and also this column to factor. So that's why after this, using this pipe, the result I send it to this, then after that I send it to a map, and then after that I change it to a factor. After changing it to factor, then after that you're going to see that the map function will return a list. Let me show you that. So if you can see, the the result the map function returns is a list. We're going to it's a list, but if you get this list, you can change it to a data. So this is so you can change it to a table. So you use the table from the table function from the table package. So has table, then after that it changes to factor and then it brings for you a data frame. So however, to do this, instead of using these two lines, you can use that map table, map data frame, map df function from the power package again. So let me show you that. So let me show you that. So I'm going to delete this. I want to return a data frame still, so you can instantly bring up the data frame without the table, without the as table function. So this is going to produce the same code as the previous one. As you can see, it's the same result but with 4 lines of code. So this one is just introducing you to the map function. That the map function does, it's always going to bring for you a list. But then the map here is always going to bring for you, bring back the data frame. As we go on, we shall see that it always depends on the kind of final result you want to bring up. Because, and we're going to look at more functions below. So let's move on. At least we've seen how this map function really works. Then let us pull up the documentation of the map function so that we really dive into really get this down a bit before we move on. So because most of other functions from the power package normally have the same arrangement of the arguments. So let me pull up this. So if you look at the documentation here, the map function transforms their input by applying a function to each element and returning a vector the same length as the input. So, like we said, like it return the same number of what? It's the same number of what? The same number of columns that we passed it on to the map function. So if you look at this is the list of atomic vector. So I want to show you that the first argument you pass in is going to be that is the list of vectors or a data frame or a list. So then after that, this function is the one which is going to be applied over all these what? These elements of the list. So the same function is going to be applied throughout all this, the whole of this. So it's saving you to write overwriting code like maybe the first column and then you write it like has data frame. Then after that again you write has data frame for this, and then has data frame for this. So that repetitive task of you overwriting that same function, they save you that. So that's the main importance of this. So as you can see here, this one returns a logical value. This returns a character, integer, a double. Then so let's go back to this to the script and continue. So this, at least here you've seen, it's actually very simple. These are the 3 dots. These are the arguments that should be passed on. Remember that there are some functions that have other arguments. So you pass in here the arguments you want to be in this function. You look at this, the additional arguments passed on to the mapped function. So that's the function. If you have a function and then you want to pass on to it the other function, you get the other argument. So you put them here after the comma, just list them. So that's importance of three dots. So, uh, so again, now here, I want to show you that. Remember here, I had to use the select function. If you can see this, I had to use the select function, and then after that, I can map. But however, there's another uh, there's another function in Power Package which is called map add. So when you have map add, you know the kind of you know the exact variables you want instead of you writing select again. So if you look at this, we can save this code and we reduce it and we just pass into we just pass on those columns column names into a we concatenate them together to form a vector and then we pass them to the map at function. So the map at function is just going to map exactly at those points and it's going to return. Remember here we just returned 1, 2, 3, 4, 5 columns. But what if we really want to modify, we want to change as factor and again we still remain with the data frame, which is the empty cast data set. We want to get the same exact columns back. We want to get the same columns back. Just it like this, the console to see that. We want to get the same exact number of what? We want to get the same exact number of columns and then again, but these other factor variables changed. So if we want to do that, we can use this to add and then after that we change to factor. Again, we're saying that we want to change it to table because if we do this, so if we do this, is that now we have changed to factor. If you can see this, that this cylinder and there are all these other variables that have changed to factor, but again they still remain with the original data set. So you can use the map at function to save this line of code and to retain this the original data set. So here they can we can because this was getting the factor variables, assigning them there. But now here we're going to just remain with empty cast data set. But again with the modified whereby the rows, so those which are supposed to be factor are factor and those which are supposed to be numerical are still numerical. So if we can look at empty cast again, so if you can see that's beautiful. You can see that cylinder is still is now it's factor and so and also there's transition AM and gear are now factor. So you see how helpful the map function can be. We can save a lot of writing code around. So here we're going to move on to if you now this is when you want to get the numerical values in case you want to apply because the other time we got the factor variables. But again now if you want to get the numeric again you can use select and then you negate you use this minus. This is from deep learning. Then you get the numerical, but it's the same concept as the factor variables. Then after that you apply the map function. So let's leave that out. So now we let's go to map. We're going to use the map to function. So the map to function, you pass on like the first you pass on like two lists, and then after that you want to but this kind of just because this is empty cast now this is empty cast numeric. Uh, let me put this let me just put this numeric here because I wanted to get and use this numeric here. Empty cast numeric here. You see this empty cast numeric. So we have the numeric value these numeric values here. And now we want to get the first one. This is MPG. And then after that this and then after that we want to add them up. So it doesn't make sense, but it's showing you if if you have if you have two variables and you want to modify them. Or now, for example, here we want to add this 21 to 26 independently, and we form another column. So we can use empty, we can use map 2, and then after that we pass in as table. As you can see, uh, this is 21 plus 160. That's we're going to get 181, and here you can see that 181. Then it's the corresponding values, so it's the same throughout. So in case you want to do such a thing, you can use empty map 2, and then map p map. That's almost the same thing as the as the as the map 2, but this one can take in more than just two columns or two lists. So this one you have to you have to you have to, you can have more than just two lists, and you apply the same method with this rather than just using two alone. But again, it's just the same concept. Now, so let's move on. Then I talked about having the map returning a list, and then if you really want to return a character, in case your function is this function, you're applying this one. Here we just apply that factor, but in case that function you're applying is returning a character, and you want you want the map function to return a vector of characters, then after that you have to use map car, but again it's still the same logic. Then after this one, they're going to bring back a numeric value, and then this one is just going to bring up a data frame with column combined. So then remember, it's the same thing that you would use just the data frame, but this one, in case you have two data frames and like they're passing through the map function and you want to combine them at the end, to combine them column wise, and then this is row wise. Then we have the map. This is going to return the integer, and this is a logical vector. So it just depends on the kind of endpoint you want, and that's a vector to return. So this, remember, this one is just returning a list. So in case you don't want a list and you want a vector of something, you have to use that. So I think everyone gets this. So now let's move on to invoke map. Now, of course, previously we are applying a function to a list of columns or a list of anything. So, but what if we want to apply several functions to maybe one variable, even or more? So this is that's when we use invoke map. So you get your list. Now, for example, I'm going to apply empty cars 1. Remember, empty cars 1 is MPG. Now we want to use MPG, but under MPG we want to get the sum, and we get also the mean of MPG, isn't it? So we're going to say, okay, we are going to invoke map, and then after that we put this in the list, that the sum, which is a function, and also the mean is a function, but we don't have to put you don't have to put the brackets, the parentheses. So if we do this and you see the result, so it's going to bring for you a list of those numbers. So this is going to be the sum, and this is going to be the mean. So if in case you just want to include that is the standard deviation, let's see, you can see that the list is going to okay. Reason and is that means okay. I think it's all about the format of what I've used, but again, yeah, it's any function that is applicable to that vector. I think you really get the concept about me. I'm just trying to get something. If I can put it on the same thing, I can apply it to a vector of numeric values, but I'm not, because it's the same vector, and I'm not thinking about anything right now. So, but again, you get the concept. But in case you have any other function you want to apply to this, then after that you can easily do that with the list of functions. So now there's another function called blank. When you use blank function, that means you want to get a specific. For example, you want to get a specific. Remember, in the you can easily say that you want empty class. You want empty class, but again you want to get the cylinder column. Are you seeing that? But if you can, instead of using this, you can use the the power function called blank to to again extract out that cylinder data or cylinder column, but it comes out as a list. If you can see this now, we have accessed the exact values in the cylinder column. So then after that, again, you can, instead of using the actual name of the name of the list, you can use its index. Remember, it's the second in empty cars. It's the second column in empty cars saying that. So you can easily use also its index and also extract out the same information from there. So if you can see that, this is where you can use blank function. So here there is cube function. So these are the several functions that can easily help us to extract out some sections of the data. Let me show you that because these are some things that these are some functions that are having the same kind of concept, just that they have a specific a specific action they are doing. Let me show you that in the cheat sheet. So let me share my screen. Let me share with you a PDF. As you can see, I've sent you this. I've sent you this in the group. If you can see the blank as I've stated above, like you can easily extract out a single value, and then if you want to keep, maybe or select. Remember, we used to select some elements, but you want to keep with something which passes a certain logical concept, like maybe it's numeric or something like that. So you can use the keep, and then so discard. That means it doesn't pass doesn't pass the logical test, and also compact and also compact. This one is just going to drop empty elements, and also head y. That means you're going to extract out from the top to up to when a certain element is null. So when it's null, or it doesn't or it doesn't pass a certain one, it doesn't pass a certain test, that means it will stop there and it give you the head part, or you can do the tail part. So then there's other functions. I'm not going to go through each and everything in the in the cheat sheet, but I'll at least if I've given you that they have a start. But these are more, if you read them, they're more they're self-explanatory here. This one. So let me go back to the R script. So now we're going to move on to modify function. So what if you want to modify a particular row and you want to apply maybe a multiplication or a summation or an addition to a certain number? Maybe you want to change the units, maybe from hours to 24 hours to maybe 12 hours, something like that, or any other kind of units, maybe from millimeters or to millimeters millimeters maybe to kilometers, something like that. Any kind of change you want to conversion you want to make. So this is where I'm going to get that cylinder. Let me change this. It doesn't make sense, but let me change horsepower. Let's change to horsepower. So then, so when I use horsepower, then I want to multiply it by 100. So I will use the modify function, and then I multiply the value. If you can see horsepower here, this is having 110. So this is having 100. This is actually having uh, 11,000. So if you have that 11,000, that's what you need. You want to just wanted to multiply that to that. So you can use the modify function. So again, this is for the weight, but it's still the same logic as the first one. And then again, if we have seen the map at function at work, again, this is just going to modify the weight, and then but it's not going to the weight of the car, but it's going to return the whole data frame. If you can see that, it is the weight is 262, that's 262, and then here it's just 2.62, and here it has just multiplied by 100, but again it has to return the same data frame. So it's the same logic, but in case you want to maybe multiply those numbers which are numerical by 100 and to leave out the categorical variables, if you can see that, that's kind of beautiful. You can see the 100 being multiplied around. Of course, depending on the kind of scenario where you are facing with and what you want to do. But the modify function is also there in the power package. Then let's move on. Let's first create some variables here. I want to talk about the append and prepend and also the functions. So here I've created a list. If you look at X, so it's just let me first. It has already gone through the for loop page. Before the for loop, I want to show you that the for loop. Let me first move X. And this RM just remove the any variable you have created from the console, from the environment. Sorry. So here there is no longer X, and I can also remove Y. Just showing you that in case you don't know. So you can remove that. So even also now you can remove if you want, but that's okay. That's enough for now. Let's use X. So let's put in X. So I wanted to show you X here. So here we have a list of just a list of one vector. Actually, just this is one vector. Also, just have a list of one vector, 1 to 5. But again, what if we want to add on a certain element on this list? That means it will be just an individual number added into a list having one vector. So that means X, your X, and then after that you append 6. So if you can see, we have one element in this is 1 and then 2 elements in that list, but this is a vector and this is just one value. So you can say, well, a vector one numerical value. But again, most times where you would really use this append function is when maybe you have a for loop, and after making certain calculations on, then for example, I want to multiply each value in this sequence 1 to up to 5, and then after that I get the results and then put back that value to the put back all those values in the same list as the X value. So to do that, if you can see the for loop, I have a numerical value which is X. So when I get that numerical value, which could be like 1, then after I multiply it by 10, then after that I put it in Y. After that I append Y to X. So that's what the for loop does. So after that, you can see that. So let us look at X now. If you can look at X now, it's having this vector, and also these other values up to 50, multiplying 1, 2, 3, 4, 5, but also multiplying them individually 1, 2, 3, up to 5. So you can use in any scenario you want, if by but this is why it could be really applicable. So this is just append, and append adds the number to the at the end of the list, and then prepend will add the number before the list. So it was like, for example, it would add this value starting from 1 to the end. Yes, that's what we will do. So let's move on. Uh, let's move on. So if we look at this, okay. So I just wanted to. There's some functions I just because of time. Yeah, I'm going to. I will just look at them when we go to the to the cheat sheet again. So just wanted to, I want to let's wrap this, then after that we go to the other side of the cheat sheet at once that I explain everything. So I'll explain split, splice, and also the reduce function at once. So now again, let's create some other. So this one splice mainly it's going to, like, for example, if you have two lists and you want to have one single list with them. So like you already have two lists, but again you want to make a single list of those two lists. So for example, here we have X and also we have Y. So if you see those are two lists, but again, if we have these two different lists and you want to put them together, you can use splice. And then after that, you see we have a list of, if we see, then we just put this, okay. So if you can see this, I just wanted to show you that this is a list of two. This is a list of two lists, so it's a list of lists. So so that's the kind of splice, what splice does. Then after that, we can also look at the cross. The cross enables you to, like, okay, here you have to make sure it's here you can do it even when you have lower, when you have when you're having lower, not the exact number of elements, but here you have to have the same exact number of elements, because it's more of an element matching format. Like if you have one, it has to match with 100, two has to match with 101, something like that. So if you want to have something which is whereby the elements in each vector are following themselves, you can use cross to see this. So that's more of that. Let's move on. Yeah. So again, this is where I wanted to show you something, that there's what they call nested data frame. So let us use the iris data set. Again, also this is comes in R Studio with R. It comes with R, part of R data sets. It's a famous data set. At least you have seen it somewhere. So this is the iris data set. This is about flowers, and these flowers are of different species, but of course different species having different petal width, petal length, and petal width, and also petal length. So if we have a factor variable, this is kind of a factor variable that is grouping these variables. So what a nested data set is like, you're going to have a data set having values or rows representing a data set. That's more of, let me show you. So this is the iris data set, but then let's just group it. If we group it using the deploy package, deploy function group by, is a table, but which is having 150 uh, uh, rows, but again, it is having groups because they've grouped it by species, which are three groups. So these are three species. So if you have grouped them by that, here we can talk about nesting. And if we nest, so the remaining data sets are going to be grouped into the exact 50 by 4. So this is the data set itself. So if let me do this, and then after that I show you that if you see if you can see this, if I hover this over this, we want to see that this is all a complete data set, and also this is the complete data set. So this is a data set of data sets. So it's like a nested data set. Yeah. So uh, let's move to now again. This is going to illustrate how the Purr package helps us to how the Purr package is going to help us to iterate over this or kind of manipulate such a data set. Sometimes you want to do some specific things, or you want to do some specific, you want to do maybe fit a model or do some manipulation on specific categories of the data set. So this is already given to you into nested data set. Then this, so first of all, you're going to get a function you want. So right now, I want to fit the model. Remember how the data set looks like? Now, first of all, I want to fit a model that is going to a linear model. We looked at linear models last time. So we want to fit a linear model that is going to predict the spectral length. But then this is going to be like the dependent variable, and then others are going to be the dependent. This is going to be like the dependent variable with the dependent variable, and these are the independent variables because it's going to be depending on these variables. Otherwise, you can call it the target, and then you can call these ones are the predictors. So if this is our target variable, and then these are the predictors, so you can use the dot to indicate that you want all of them. Then after that, you use a data called data frame, DF. So this DF is going to be passed on to this function, and that's what we shall use here. So we create a function which is going to be fitting linear models on any data set which is passed on to it, as long as it's having these column names. So, but again, if you see that our nested data sets are having those columns and also having the target columns. So what we shall do, we shall come here and we're going to get our nested data set, and then after that we are going to mutate. So that means we're going to add on to another column called a model, and then we fit a model using the map function, and that map function is going to take into the data. Then after that we fit a model, a linear model. So that's what it's going to do. Let's first look at it. So if you can see that, so this is a linear model that has been fit. So and then also that. So this the final data set again is still another nested data set, but with another extra column of the linear model. So if that's a fitted linear model, that means we can also access coefficients. So what if we want to access coefficients of all those categories at once? So again, we're going to get a function which is for extracting out coefficients of the model, and we're actually getting the first coefficient. So after that, again, we can use transmutate. Transmutate is more like mutate, but transmutate is going to modify everything, and it replaces all the other columns and it returns only this column. Let me show you that. So if you see the current data set we have, it's going to only return beta, and all other columns are gone apart from this species data set. So which is grouping them. So if you can see this, it's instantiating, and then after that it's mapping. This is why I showed you the application. Now this is where the application will be double. Remember, now we know that the coefficients are double, are numerical. So that's why we're using double instead of a list. We want a vector of what? We want a vector of what? A vector of what? A vector of numerical values. But again, it's still taking in a function, it's still taking in a data set or a list or like the data we are supposed to use, and then it's applying the function. So it's still the same format, however much it's within the transmitted function. So after that, it's going to give us the coefficient. So this is that data set, the final data set. So we are having each species and its first coefficient, like its first coefficient. So that's where we can use the nested data set. So again, this is more of the tied R package, whereby you want to unmutate everything. Remember, this is this is the nested data set, the first original nested data set. But what if you want to take it back? This one you can use the unlist columns. So let me show you more of the illustrations and some more functions in that cheat sheet. that one is more. It kind of okay. Yeah, how it's a mouth. It's the mouthful of what like the way it's a cheat sheet. So most times it kind of disturbs me how to pronounce that. But I think it's a cheat sheet. Yeah, so I have to mention it like kind of slowly. But anyway, let's move on. So let's go into so let's move on to the apply functions. So the apply functions. What I wanted to show you here is like more of this. However, if I would talk about each and everything here, but then the video would be very too long. It would be long, and it will be very, very boring. But I've talked about most of the things that you could really go through. However, you make very good use of this cheat sheet. I didn't create it; it was created by RStudio, and you can also get it from the RStudio website. It's free, and so you can easily get it there. So here, this append, I've talked about this. The arrays, you would look at them, but then the reduce, this is whereby it's going to reduce, and after that it applies a function having a recursive way, depending on when you really have to use these things. So this is where the nested data set, and then what I've not talked about, like that this can be called the list of column one. It's a list column. So this most times, like if you get a nested data set, so it forms a list column. And now this is what we are seeing is how to handle a list column, or how you can easily manipulate a list column. This is the kind of workflow. Yes. Basically that's it. However, you make good use of of course I've said I've not talked about some functions, but you can easily, if you really, this can really give you a very big good start. And if you really like listen to or watch this video, I think you really get more in depth and easy understanding of Purr package. So I want to thank you for watching, and you can look around the channel for more videos. We have a little bunch of videos for which concerning machine learning and data science. Thank you. Attending.